And we're live.
Welcome back to the ASMR channel.
No ASMR. Okay, Tayson, will you read this first paragraph, please? Excuse me.
By definition, a cyclic polygon is a polygon that can be inscribed in a circle.
Cyclic.
Cyclic.
Yes.
Cyclic. Ooh.
Ooh.
Cyclic polygon is a polygon that can be inscribed in a circle. That is, all of the vertices of the polygon lie on the same circle.
So that means that if you can draw a circle in which all of the vertices of a shape will lie on the circumference of the circle, okay? We talked about this in 5.9, Centers of a Triangle, on our work on Kara's notes and diagrams. It should have convinced you that it's possible to locate a point that is equidistant from all three vertices of any triangle. Therefore, all triangles are cyclic polygons, okay? Do you remember how we can find those? It is with the compass. What point do we need, though?
Or at the long leg and short leg. I can't. Points B and C, I think. It's either B
Interesting.
or B.
Well, it will be something with the compass.
No.
Did we just find the perpendicular bisector of them? Something?
Yeah, so as we've been talking about this, right? The perpendicular bisector is equidistant from the endpoints from which we create, right? That we create. That's part of its definition, is it bisects it. So that means it's equidistant from both sides or from both endpoints. So if we were to do the perpendicular bisector of two sides, that should give us a point that is equidistant to the three vertices, right? From all three vertices. So what I want for you to do is I want for you to construct the perpendicular bisector of any two sides of each of these triangles. Okay? Make sure we are constructing them too. Make sure we construct them with the compass. Okay, I'll give you guys a couple seconds to finish that up.
These markers?
On two sides?
Two sides of every triangle also. That looks awesome. What do you want about it? He's angry and frustrated. Get out of here with it. It's gas, Mia. That is gas.
Mr. Ball, we don't have questions. I must go very confused.
Yeah, no, remember the golden rule of thumb. Only ask questions and answers you really want to know.
I learned that one this morning.
Yep.
And then doing it again.
For every single triangle.
Of every side of every triangle.
Mr. Hay, stop showing up for the freshmen.
Yeah.
A lot of circles.
Mr. Hay.
Thankfully you have a compass.
Wait,
you're
are we
not
drawing like
freaking
a perpendicular
You're finding the.
No, don't move. Okay, it didn't move on me. Hi, Mr. Bull.
Perpendicular bisector.
Yeah.
Yeah. Yep. Okay. Cheese text. Cheese text.
We were seeing that and just the whole set of there.
Nice.
Mostly
cheese.
What?
No.
Hey, just construct them and don't say words, please. Tayson.
Because it doesn't want to be.
Okay, you all finished?
Nope.
Did you also draw the circles too?
Yes. Yeah, but then I like erased it to where they were lightly showing,
Okay.
so that it's not so much.
Yeah. And was that shown to actually have all 3 points land on the circumference? Yeah?
Yeah.
No for anybody?
Well, it should land on all 3 points.
Yeah, does it?
Yeah.
Okay, great. So cool. Since each vertex of the inscribed angle lies on the circle, each angle of the triangle is something we call an inscribed angle. Now we know that the sum of the measures of the interior angles of a triangle is how much?
180.
180. And what is the degree measure of a circle?
360.
Yeah. So what might that imply about the relationship between the 3 inscribed angles and the arcs that they intercept?
I think I managed to get some things wrong on the math test because I thought a circle was 365.
How?
That's how many days are in a year.
Yeah,
Depending on the year.
technically 365.24 yada.
That you know.
Great. Yep. Thank you for that.
Yes.
All triangles. fit
Okay,
in a circle, is that
so
what-
here's my haphazardly drawn circle. Because I don't have. I wonder if they make compasses. How would that even work? Never mind. So,
Good work.
what is the relationship then, do you think, between an inscribed angle and an arc it intercepts? So, like, for example, we have angle A, and it intercepts arc CB. What do you think the relationship is between their measures?
You okay, Compass?
Shh.
Yeah, you okay? I dropped it and now it bends.
Okay.
See?
Yeah, that. I'm sorry for your loss. Will you answer the question at hand?
What?
What do you think the relationship is between the arc that that an inscribed angle intercepts and the inscribed angle itself?
I think
Its measure.
probably the angle, like, is going to be the same as the degree to which the arc is all other arcs.
Okay. If that were the case, then wouldn't we need to say that either a circle would have 180 degrees or a triangle would have 360 degrees? If they were the same? Right? Because A plus B plus C,
Well, are they similar in that case?
what do you mean?
In like what 2-to-1 ratio or whatnot?
Oh, a 2 to... So that wouldn't necessarily be similarity, but you might be onto something, because if the 3 angles of a triangle add to 180 and a circle is 360, how much is 360 compared to 180?
Double.
Yeah, it's double, right? So then what that implies is that maybe this intercepted arc is twice as long as the angle that it is referring to.
Is
Yeah,
that okay? Sorry.
You're good.
I will work on that.
Thank you.
Okay, so that means that the inscribed angle is going to be half the measure of the arc it intercepts. Okay? So let's say arc CB is, let's just say for funsies, it's 50 degrees. What would angle A equal?
25.
Yeah, do we concur about that? Because it's just half, right? 25. There we go. How about if we had C being, I don't know, maybe like 190. 190. Or arc AB being 190. What would C be?
I can't do that math real quick.
It would be 95. Very good. Okay? So you can see this relationship, right? All right. That's what you need to show and state, right?
So how would you write that down?
You would have to say something like the measure of an angle is half the measure of its intercepted arc. Sorry, measure of an inscribed angle. That's pretty important. Critical, even. measure of the intercepted arc?
That looks like an R.
What looks like an R?
The M for measure.
Half the measure of the intercept.
I thought it was an R, so I was like, what in the world?
Yeah. Oh.
And Mr. Ball, is that pig about to dissect us?
No, probably not.
Instead of, us dissecting
Every
his
time I
brothers and
see that
sisters?
pig, I always think it says shut up,
Yeah.
but it's a suit.
Yeah.
It does say suit up. Yep.
It looks
See,
like
I
a
just
shut
think
up.
of Animal
It
Farm.
does.
It's like, come on, we finally
I hope
got
the cake
snow
ball's
ball,
gonna be
let's
outside.
Okay. Who wants to read this paragraph?
Sure.
Thanks.
We know that the degree measure of an arc is by definition the same as the measure of the central angle formed when the radii that contain the endpoints of the arc by the radii that contain the endpoints of the arc. But how is the measure of an inscribed angle that intercepts this same arc related to the measure of the central angle and the intercepted arc? That is something useful to find out.
So that's saying this central angle has the same degree measure as the arc it intercepts. Okay, central angle, where its vertex is on the center, right? We just made the conjecture. Actually, we were kind of zipping ahead. Probably shouldn't have done that. Oops.
Such is life.
So what is our conjecture about the inscribed angle?
Let me flip the page. Measure of inscribed angle is half the measure of I can't read that arc.
Intercepted?
Intercepted arc. Good job, Jason.
Nice.
He tried.
Okay, very good. So, yes?
Because there was the one, I don't remember what it was called. Vocabulary. The inscribed angle, would that be the same as like the central angle if it were to keep going? Like would it still be like the same idea?
How do you?
Say that again?
So like would the inscribed angle, would it still be like the same of like the inside angle is the outside like half the outside angle or
Like this?
yeah, would it be like still half the I don't know how to
Is this, are you saying is this half of this?
like would it still be like that same
Yep. And we're actually going to prove some things today about this. So, what we are looking at right here, this whole paragraph says we are going to prove that the inscribed angle is half the measure of the arc it intercepts. Okay? And we're going to, yeah, I did buffer. My controller died. We're going to use the fact that a central angle, by definition, has the same degree measure as the arc it intercepts. Okay? So we are going to name this circle circle.
circle? We're gonna name the circle circle.
What should we name the circle?
Howard.
How about ABC?
We're going to name it J.
Why not Howard?
J for Jacob.
No.
Okay? We're going to name the circle J. Dang it. Okay? All right. And we are going to prove now. Well, what do we need to prove?
Line on the J.
Glad we all don't.
Oh.
You just need like first and J.
The inscript
That
angle with the diameter lies in the
CJB
interior.
is, measure of CJB is equal to half measure of arc CB.
No, they are equal to each other. So CJB is congruent to the arc CB,
Is that
or is equal to the measure of arc CB, rather.
central angle?
That is a central angle.
Do we have to prove that that's an arc? And
What, BAC equal to arc?
well, you don't have.
That's
to
what
prove
we're
that it's
trying
an
to
arc.
prove. Yeah, we don't have to prove that it's an arc. It's by definition an arc. What we're doing is we are proving that this angle, angle A, is 1/2 the measure of arc CB. Okay.
If you get good at this, you could probably aim it at somebody and hit them.
Yeah.
Okay, let's focus.
Itself with it.
Focus.
I said if.
Or we could also say that Yeah, we'll do this.
Goes half measure.
See that little hat that CB wears? That states
This is
or denotes arc.
This is lucky baseball cap.
Kind of looks like a barn.
Thank you. Okay, so they have given us a hint to say look for isosceles triangles. Do you guys see any isosceles triangles in here?
Is that where it's
Yeah.
Two of the same sides, yep.
Triangle JCB.
I don't know.
These isosceles, ain't it?
JCB, yeah, which two sides are congruent?
JC and JB.
How do you know that?
JB, like Jared Bond.
Oh, they are radii. Yeah, exactly. So if we have two radii that are congruent, that means that we have an isosceles triangle if we build a chord or build a triangle including a chord. What do we have another isosceles triangle?
JC and JA.
Yeah, so we've also got JC and JA as congruent, right? What's true of what do we know about isosceles triangles? Why would they tell us that hint?
Two angle measures of the sides are equal.
What?
So you have your central angle, and since these sides are the same, these angles are going to be the same.
Okay, so the sides opposite, or the angles opposite the congruent sides are congruent. So that means that A is congruent to JCB, sorry, JCA.
Are the triangles proportional?
They're not proportional or similar, no.
Would angle JBC be the same as angle JCB?
I've got pretty good at hitting the water ball.
JBC and JCB are also congruent. Yeah, we could say that this is congruent to this. But they are not necessarily congruent to angle A and angle ACJ. Okay. Okay, so there we go. Shh. Do we also know, so we know, shh. We know that angle CJB is congruent to arc, the measure of arc CB.
Yeah.
Please just leave that for right now. That'd be great. Just leave it. Thank you. We know that it's congruent to arc CB. What do we know about an exterior angle of a triangle? Like this angled CJB relative to triangle AJC.
It can be.
It's 180.
Okay, it does form a linear pair here. What else do we know about it?
It'll be equal to angle A plus angle, I don't know, ACJ.
Yeah. Do you guys remember what that's called?
Remote interior angle?
It's remote interior angle. So this angle right here is equal to these two angles added together. Okay? So we're going to use that to help us to prove that angle A is half the measure of angle arc CB through kind of a little labyrinth that we're going to weave here. A verbal labyrinth in our proof.
Oh, like that.
It's going to be awesome.
A labyrinth that we're going to weave.
Verbal, have you ever read House of Leaves?
We're going to weave a labyrinth here.
That has a verbal labyrinth in it. But
Nice.
it's a literal labyrinth.
Oh, I've heard of that actually.
It's fun, because, yeah.
So in every proof, we need a statement and we need a reason because we can't make just statements without reasons. That doesn't make any sense.
I don't like proofs.
Any diggity doggone sense?
Proofs are mean.
That's not true. Okay, step number one. What is always step number one? The given.
Giver.
Nope, given. And what has been given?
Measures angle A equals 1/2.
Yeah.
No, that's what we're proving.
Oh, that's what we're
Yeah. That would be sick if that was given. Just be like, done.
Yeah, that'd be nice. I mean, it is given.
Dunzo.
Anyway, that's
It's like
Nothing
this
would
way.
be that easy.
Given.
Believe
dot,
that
dot.
measure of angle A plus measure of angle C is equal to measure of angle J.
So that will be, that's not given to us. We'll use that later, and our reasoning will be remote interior angles.
Okay.
would it be?
The sausage triangle.
Also not given to us.
JAC is, no, that's not given either.
The angles.
JAC.
What?
Congruent to
J is the
JC.
midpoint of the circle.
So we can say we have circle J. That's one thing we can say.
That took a while just to get circle J.
It's so cold.
It is rather
Oh,
chilly.
J.
Okay, so circle J. And what else does it say up here?
That eight distance I was circles diagram.
What do we know about circle J? With what?
It's the diameter.
With diameter AB. And do we know any other parts of this circle?
Radius JC and arcs AC and BC.
So the arcs will be kind of implied, they'll be given to us, or we don't have to state that. But we can say with radii AJ, JC, sorry, JA, JC, JB. So I'll say and radii JA, JC, JB. Okay.
And they're gonna be like, oh my god.
Oh my gosh. Nope, not that. All right, I reckon that's probably good for the given. It's about what we've got. We've made some markings here, but we don't know anything yet, really. We know what we're trying to prove. Okay. What do you want to talk about next? We talked about isosceles triangles. We talked about the central angle being congruent to the arc or being equal to the measure of the arc. So what do you want to state next? What do we have to say before we can say it's isosceles? Because order matters, right?
The sides are equal.
We have to state that JC and JA are congruent, right? So let's go ahead and say that. JC is congruent to JA, right? Order matters, yeah. Why can we say that JC is congruent to JA?
Because of definitions, yeah.
No, we can say that because they're congruent, then we can say it's an isosceles triangle, but we can't go the other direction yet. We have to say that they're congruent for a different reason. It's because they're radii. Yep. So definition of radius. We have to ask ourselves, how do we know that they're congruent? Now, if we had been given that it was an isosceles triangle, then we can, but we haven't. But now, what can we say?
That they are, that it's isosceles.
Now we can say triangle AJC is isosceles.
Should we give which two sides it is isosceles with, like, or no?
Well, we just kind of did.
Yeah, JC is congruent to JA gives us that. And the reason for that is definition of isosceles.
Really?
Are you the kind of person to dip those Nature Valley biscuits into ranch, Mr. Wall?
Gross.
No, like
Please stay on task. That is
That's
in your
just
coffee.
vomit inducing.
I
Ugh.
see you dipping them in your coffee.
That's not exactly criminal, though. That's just normal.
Honey
Ranch,
mustard.
though?
Ranch would be criminal. Straight to jail. Okay, what should we say next?
JC and JB are congruent.
We could say that, but do we need to know that this is an isosceles triangle, JCB? I don't think we need to say that. So we don't need to say that, although we could, it won't help us.
Would it be now that would we go into like the angle?
Yeah, maybe let's talk about something about the angles. What do we know about the angles of this figure?
Measure of angle A and measure of angle C is equal to measure of angle J.
Yeah. We will have to write those a little differently because angle C is ambiguous. I don't know if you're talking about this or this or this. So we're going to have to define what we're talking about. Same with J. But A is fine because A is the only angle over there. So let's just go ahead and define that as saying the measure of angle A plus the measure of angle ACJ is equal to the measure of angle CJB. Now, why can I say that? Don't answer yet, Tayson. I want to see if everybody else remembers.
Remote interior.
Money, dude!
Why are the lights off in the hallway?
They can be, and I like it.
Okay, what else can we say? So now we've stated...
Can we turn the lights off or is it
Not
too
all
dark?
over, like,
It's too dark.
like
No. Just let's keep focused,
It's
please.
remote of interior.
It is remote interior angles for the reason. What else can we say, though? Because remember, we need to get from arc CB all the way to angle A.
Okay, so CJB equals CB.
Great. The measure of angle CJB is equal to the measure of arc CB. Very nice. Why could I say that?
What is your definition of central angle?
Mm-hmm. Whoa.
hey,
Samantha.
it was bleeped.
What?
Yeah, how dare you even think the word, Mr. Hall?
I'm never gonna give
Every
you
time
up.
I hear it,
It was bleeped.
No, I know, me too, actually. Low-key.
It's just like,
what is happening?
Okay, so measure of angle CJB is equal to the measure of arc CB. So now we kind of have built something over here that says those two angles of the triangle equal this central angle, and that central angle is equal to
can we cancel?
CB.
You gotta substitute them first, then you can
Oh yeah,
cancel.
substitute.
Okay, so we could substitute stuff, right? So we could substitute CB for CJB, right? Since they're equal. So then I could say the measure of angle A plus the measure of angle ACJ is equal to the measure of arc CB by substitution.
That was beautiful.
Thank you. I've been practicing
Yeah, I can tell.
my whole life for this moment.
For this
I'm gonna get copyrighted for just having a voice that's like as good as like Ariana Grande. That's what they're gonna be like. How does he sound so much like her?
Grande, Adele, Cardi B.
What?
all of them.
The
Cardi B. One of those is not
A
like the
riff?
other.
Yeah,
Can I? Which riff?
just any.
Like Beethoven.
Just like any type of riff, just.
I sort of can, but my vocal control is not. It's better on the way down.
Like you got
Then on the way up.
I wanna
You
hear
got
it.
No.
Beethoven.
Lizzo, what?
Okay,
After
shh.
we can finish this.
Maybe. So now we're really close. We've got angle A and ACG, but how do we get from angle A and ACJ? Sorry, ACJ, not G. How do we get that to being like half to just regarding angle A? What?
Measure of angle ACJ is equal to measure of angle ACJ because of reflexive property.
That's close.
No, wait.
CP.
We need to go from ACJ to A.
Yeah, them is equal to each other.
How do we know?
Because of the.
That's isosceles triangle.
Yes! Measure of angle A is equal to the measure of angle ACJ. Why?
Because of.
Diff of
Notification
isosceles.
ESPN.
Thank you for notifying me of that, Tayson.
What is your ESPN like?
Oh, it's great.
It's probably all golf.
Most likely.
Okay, now that I have that,
Oh, God.
let's go ahead and put A in there as well. So the measure of angle A plus the measure of angle A is equal to the measure of arc CB. Again, substitution.
You should go into the voice.
Already got one.
All of the students just show up in the audience, just.
Yeah,
That's-
Waiting.
sitting there in our school uniforms, like, hello.
This is the voice.
Or American
That would be
Idol.
awesome.
Yeah, you gotta make sure you're
Just
right.
Mr. Ball walks on stage, all of us.
You guys are ready?
It's all like-
I mean, hold it.
Okay, number 9. What else could we say?
I'm running out of space.
I am too.
We're almost there.
Are we though?
That's what we.
I'll tell you. 2 times the measure of angle A is equal to the measure of arc CB. Shh, focus please. That's just the definition of multiplication.
Addition.
Repeated addition.
W. Lizzo, what are you doing?
Focus.
Don't look at her.
Focus.
She's standing on her.
Focus.
I am focusing, just not on that.
And that you said that was multiplication.
I've never seen
Yeah.
her stood up.
Yeah.
She is wildin'. Okay. Now we have 2 times the measure of angle A is equal to the measure of arc CB. So what do we need it to say?
You need to do canceling.
Canceling.
We needed
Yeah,
half.
so you got the 2 and you don't want the 2. So, yep,
So what do?
you divide.
Divide both sides by 2. So the measure of angle A is equal to 1/2 the measure of arc CB by the division property of equality.
What?
Can I just do the symbol for division?
Sure. It's a great idea.
Are you that struggling for
Yes.
We are done.
time for you.
Dot
Boo,
time.
boo.
The
Boo,
dots.
boo, boo. Yay! How satisfying was that, you guys? Oh, that was so satisfying. Look at how beautiful that
That is
is.
not beautiful.
Mm.
That is torture.
I just went all over the page, you know.
Look, all I'm saying is like,
Hey, we're
it's
like
good to
starting
appreciate
off.
art
We
and it's
already
good to
have a
appreciate logic.
page and then the back of that page.
That's a lot.
Nice.
We're doing
Okay, so here's what we're gonna do. Okay, because
So cold.
so I'm not actually gonna go through these entire proofs. We've already proven this one time, right?
Okay.
Because of the diameter.
You
So if I just look at this arc and this arc being twice this and this, I just add the arcs together and I add the angles together and it's still 1/2 by those properties of addition. Okay? Similarly, if I were to do this one, wow, nice line.
It came off slow.
This one, and this one, notice how I'm rebuilding each of these with diameter lines so that I can use my proof in case 1. Then I could say it is arc SQ, let's call this Z, SQZ minus arc RQZ, and then by the properties of subtraction now they're still equal to 1/2.
Okay, the way you made that Z just looks like, I think like
Ball,
the,
would you say
it's either a
RQZ
pound or a
would you just
euro
say
sign. I
RQ?
can't remember which.
Angle RQZ is what I was saying. So SQR is 1/2 of SR, RQZ is 1/2 of ZR.
Got it.
The hint is
I
not
don't
really a
remember.
hint. It's a question. I'm just kidding. Can you see in case 1 and case 2?
Can you see what I see? Okay, now we are going to move on to part 2. Part D. We found that all triangles are cyclic polygons.
Oh, cyclic.
Now let's examine some possible cyclic quadrilaterals.
Sounds like a
square.
compliment. It's like
Okay.
devious
Square.
lick, except the word.
Yeah.
Don't say a square one.
So it's interesting, actually, you guys. I was just talking with one of my friends, and we were talking about like modes of thinking, and we were talking about how we like think about our futures differently because we were talking about like wanting to buy a house, and this person talks about like, oh, these are all the possibilities, and these are like the things that I could do with this home. They were dreaming about it. And I was very quickly like, oh, well, it wouldn't work because the foundation of that house isn't awesome. So, like, I wouldn't even consider that. And we were talking about this in different ways because this person's mode of thought was saying, what are some positive options that we can do? And my mode of thought was like, is there a way that I could disprove this or give a reason good enough for not doing something so that we don't then take up thought power to think about like the dream versus actuality. And it's almost like realism versus optimism or pessimism versus optimism. But the mode of why I think that way is because in math, you're constantly trying to come up with one thing that could disprove whatever you're saying. Because if something's true, that means it has to be true always. As soon as one thing disproves that, it is no longer true, right? It is now sometimes instead of all of the time.
There was actually this study done, and I think the main premise of it was that I give this sequence 2, 4, 8. What is the rule for this sequence? And they asked a bunch of people, and it's like, hey, you can give me your sequence, I'll tell you whether it matches it or not. And what most people gave was like 6, 12, 24, whatever, trying to match it, but in reality, it was just going up every time. 1, 2, 3 would be the sequence, and because nobody tried to disprove it, they never got that. They always thought it was doubling or something like that.
Right.
They were just trying to find something that fit within it.
So someone who is doing mathematics, who's trying to find a theorem or is trying to make a statement of truth, you are trying to prove it by saying, can I disprove this? Because if I can it's the opposite of what we do in culture right now. We always look for people to affirm our modes of thought rather than something to say, no, your thinking is flawed. Here's how you should change your thinking.
Every second your thought is wrong. They're like, no, but that's my opinion.
Right. So like that's the idea here is that in math, you're actually trying to find ways to disprove something so that then you can say, okay, what do I need to change to either make it right or to modify this to make it more accurate or anything like that. So as we go through these questions, like under number 4, your goal here is not to say, it is to say, is this possible? Because that makes it not false, right? If it is possible, then it's not false. But then if it is possible, we also have to say, okay, well, can it not be possible too? Okay, so you're trying to find ways to disprove either level of certainty. Okay, so with that in mind, it's a whole interesting concept of thought processes anyway. But with that in mind, let's think about this. Are some, all, or no squares cyclic? That means their vertices lie on the circumference. Okay, all of them. Can you think of a square that would not be cyclic?
No, and I can tell you why there probably wouldn't be one.
Okay, why?
Because the definition of squares require that every square is similar to one another. Every square is similar to one another. If you can find a cyclic square in one case, they all must be, because I can find a point equidistant from each and every one of those vertices. There's always going to be one of those points, and therefore they're always cyclic.
Preach. That's gas. Way to go. Okay, so they are all cyclic. Okay, how about a rhombus? Some, we think? Okay, what is one that is then?
Squares.
Ah, there we go. It's tricky, right? A square could be a rhombus. Is there any other rhombus that is cyclic? So let's make this circle. If I were to try to make a rhombus like this, it would have to be like, if those 2 points were there, this one would go over here, and maybe that one too. But this point would be out of the circle, right? So the only rhombus that actually works is a square. Okay. Very good thinking, though. Okay. How about a trapezoid? All. Do you guys remember what a trapezoid looks like?
Yeah.
So this could be a trapezoid.
It could be just some.
I will say none.
None. No,
I don't
okay.
think it's none, because I think some can be.
Okay, here's what I'm thinking.
All
The definition of a
points within the circle.
trapezoid requires a set of non-parallel lines.
True.
Because they're non-parallel, they can't be like equidistant. I think.
Okay, so there's one for none. Are there any then trapezoids that could be inscribed?
Well, I'm thinking. I'm going off of the definition.
Okay, so an isosceles trapezoid, they cannot be parallel, but they can be congruent in an isosceles trapezoid. So a typical trapezoid, we've determined no. But if we have an isosceles trapezoid where those are not parallel, but they are congruent, then we should be able to get all of these points to lie on the circumference of a circle.
So some.
Yes. Also pretend like that's a real circle and not a Teenage Mutant Ninja Turtle.
Oh my
Real
gosh, it
though.
looks like that.
Which one though?
Which one? Yeah, which one?
Oh, now it looks like a pig.
Wait.
That's all the Teenage Mutant Ninja Turtles really look like anyway.
I
Okay,
love-
how about rectangles?
Rectangle.
None.
Well, squares are rectangles.
Oh,
There
snap.
has to be at least some.
I think, yeah.
Like,
Okay.
it cannot be none, so it's either some or all. And I think stretchiness is, well,
Well, don't
is
rectangle
it all?
sides aren't all. lame.
I'm
I don't think there's one
certain
that
it's
couldn't
all.
be.
I love Tayson's reasoning too. He's like, is it
Yeah, I'm-
all?
Yeah,
Is it
I'm-
all of them?
I'm
It's
imagining rectangle
yes.
and a square. I'm just like stretching it in my
Yeah.
mind, and I can always fit a circle.
Yeah.
Yeah, so when we have those 90-degree angles, we always will get a circle that can be.
So with the 90 degree.
Or an
Right
oval.
I'm terrible at drawing
Right
these.
angles
Yeah.
equals-
Yeah. So the right angles are helpful for us, right? So yeah, I can't think of one that's not cyclic. Oh yeah, how about parallelograms? Some why? Which ones are?
Because all of these beforehand are also parallelograms.
Is a trapezoid a parallelogram?
Trapezoids are parallelograms, and not all trapezoids, not all rhombus.
Wait, trapezoids
Wait, what's
aren't
a
parallel.
Trapezoids cannot be parallelograms because by definition they've got one pair of sides that's
well,
not parallel.
rhombuses are though.
Rhombuses are, squares are, rectangles are.
Yeah, I think you just have to focus on rhombuses because rhombuses
Yeah.
are a parallelogram and rhombuses
Ah.
both parallelograms will have to contain
some.
both.
No, no, it's some all and then no.
No.
There's none down there
Yeah, there are
Wait,
many.
which one is it? No.
None of them said no, but like
Oh.
I mean like just in the list, it's just like some, all of them, or it could have been none of them, but no, it's just no.
No. Okay, yeah. All right, so let's see.
Well, yeah, but if you were to say none parallelograms are cyclic, that doesn't make sense. You'd have to rephrase it.
We're going to call it today.
Oh,
Okay.
it's almost,
Suit up.
let's go.
It's almost time to smoke all.
And here's what your homework is for tonight. Okay, we're going to chop this one up. 7.3, I just want you to tackle the ready. Okay, and then we will deal with the next one on Wednesday.
Just do the ready.
Oh, thank you. Just the ready.
And the set and the go.
So we now have played around with that dynamic geometry software, and we have this conjecture that opposite angles are supplementary or that they add up to 180. And now we're going to prove that. So think about what have we been talking about so far in this lesson and the lessons in Module 7.
Arcs.
What?
Arcs.
We've been talking about arcs and angles that intercept those arcs, right? So what do you think we could utilize then to make a statement about something like opposite angles add up to 180 degrees? What kind of angles are these? Let's say that first. Vocabulary review. If we have all of these angles that are in a circle at the circumference, what kind of angle is that?
Central angle?
A central angle is at the center, right? That would be this one right here. So what are the ones that are on the circumference? What?
Is it the chord? No.
They are all chords, yes, but that is not the name. So for those of you that are not looking right now, we have a whole list of vocabulary that we could go back and look through. So if you're not currently looking, go ahead and look back.
See, it's right there, so look. Then I can memorize it, and I can think and know the word.
Okay, can you do that?
I'm thinking.
Okay.
Is it
Nope. So,
You're asking about the angle, right?
yep, what kind of angle these are?
I see this. I'm
Would
gonna
it
see
be
it.
a secant?
No.
It is not a secant.
Inscribed?
It is an inscribed angle. What is the definition of an inscribed angle?
Angle formed from two secant lines where a secant and tangent line intersect at a point on a circle.
Yeah, so it's either two chords or two secant lines or a secant line and a tangent that intersect at where their vertex is at the circumference. Okay? So we have like chord AB and chord AD that meet on the circumference. Okay? So these are all inscribed angles. What do we know about inscribed angles relative to the arc that they intercept?
It's the same. Or no, they'd be the opposite. What do you think?
We just proved this whole thing, actually. What did we prove?
I can't think of the words, but it's like
Angle A equals half
Oh.
of secant, half of
Oh, you're
Thank
talking
you.
about that arc. No, it's
Yeah.
going to be half.
Yes.
That's meant the arc that was.
I couldn't think of the words, but I was like, it's half.
The intercepted arc is this one right here, right? BCD, this arc. So if we're looking at angle A, it intercepts arc BCD. A is how much of arc BCD? It's half of its measure, right? Okay, great. Now our conjecture that we just made was what?
Angle A is half.
No, the conjecture we made back here.
opposite angles. Half to one.
Good. So they add to 180. So what could we say? We're dealing with opposite angles, right? So we're also dealing with C. So what is true about C? It's half of what arc? Yeah, it's half of arc BAD. Now, if we look at arc BAD and arc BCD, how much of the triangle do they make?
All of it?
All of it, right? And what is the degree measure of, did I say triangle? I meant circle. Sorry. How much of the circle, how much of the circle, they make up all of the circle, and each inscribed angle is how much of each arc that it intercepts? Half. So if a circle is how many degrees? 360. Half of 360 is 180, right? So if they intercept the entire circle, and an entire circle is 360, and they're half of that, then that means they're 180, right? So those are the steps of logic that we have to take. So let's go ahead and take those steps of logic formally with a proof.
Yay.
Thank you for your enthusiasm, Jacob. And Samantha.
It's too small, and then I have to write really small.
In any proof, what do we always start with? The given.
Actually, you start by writing statement.
Okay, thank you, Samantha.
Line before that.
Yeah. Yeah, that's fine.
Actually, you gotta figure out something to prove before you do any of
I
that.
actually gotta find the place where you're gonna put it because it's gonna be super long.
You gotta be boring before you can write.
You gotta write small.
Okay, what is given in this diagram here?
The
That.
ABCD is cyclic.
Yeah, so inscribed quadrilateral ABCD. Or cyclic quadrilateral ABCD. I'll call it inscribed. And I'm going to name this circle
Jerry.
J for short.
Oh. Like, what is that shape after C?
Huh?
My brain wasn't going A, B, C, D for the shape because we've done triangles for so long. So it's like, what in the world is that shape?
Triangle.
after?
Okay.
What?
What do you guys think that we should maybe do next?
Well, we've already proven that the angle is half of the. I always forget
The arc.
arc. So couldn't we say like, couldn't we say that for the second one and then say it already proven in the past?
Yeah, so now that we've proven it, we can use that as part of the definition, but that won't quite be our second one because before we can make that statement, we want to just make it clear which arcs these angles intercept. Okay, so like let's say arc A. What is angle A? What is the arc that it is intercepting? Yeah. So I'll say inscribed angle A intercepts arc BCD. Remember that arc symbol is just like a little hat? And then let's also say that same thing for arc C, or angle C. Inscribed angle C intercepts arc. Wow, intercepts, not intercepts. BAD. That's bad.
Just put ba. What would we put for the reason?
You know what? Here's what I'm going to do.
Okay.
Combine.
That's all just part of the given. Because we can just see it in the
Yeah.
in the graph. Okay?
But we just erase some things.
Just a couple of things.
So would we then do the saying it's half of it?
Yes. Now that we've said that, now we can say the measure of angle A is equal to 1/2 the measure of arc BCD. And I'm going to put the other one in there too. The measure of angle C is equal to 1/2 the measure of arc BAD. Bad.
Now what would be the reason? What would we say the reason for that is?
What?
At least something slightly clicked for math today.
Yay!
Because now I'm like, oh wait.
What kind of angles are A and C?
It's definition of
Inscribed angle.
angle.
Yes.
Darn it, you guys. Okay. I would
Sound like you cared.
just acting.
Are you in musical theater? No.
Jason, you should
Why
be
are
yourself
You're
as
not
the
in
brain.
it either.
Musical theater.
It depends. I'm going to force Tim to be in it.
Yeah, all you
No,
guys.
I'm making Tim do it with me because
You guys really
bonus is
should.
tech
What would
people
your
and Tim and I are doing
sound
tech,
music
not dancing.
I like the
It depends. If there's anything better, I'll probably do that.
Hamilton one.
Otherwise, I'm not.
Yeah.
and the
I thought that one was probably my favorite.
Sitting behind Spencer, sitting in front of
Oh, and the
Spencer.
Newsies one.
Newsy was
I
pretty
don't
good.
That's
like
my
that one.
favorite one.
Okay, so
You should see the guys backstage for the girls song.
You should see us backstage for your.
what is how could we go from here? Because now we need to start talking about the actual measures of things, right?
The two arcs add to 360.
So the measure of arc BAD plus the measure of arc BAC or BCD. How do I know that?
Because he's circle.
Is circle.
FF circle.
It is really trippy to write something here and to watch it come up there.
Yesterday during our English presentations, the longest part was just setting up the slides. Because everyone's like, slide it this way. But they were great.
They should really give you like 5 extra sheets of paper at the back of every single one of these
I
things
hate
with.
presenting, so I just forget what I'm doing. I'm like, just
Same.
taking notes, just taking notes. I thought
What do you think our next step should be?
Our next first I need to draw another proof line because I ran out of room. Okay, so
that was
we just proved that equals 360. So
What do we have the Jacob? Shh. What do we have? How could we have this help us?
Well, you have what, you don't have what the measure of the arc is, you have what half the measure of the arc is.
Yeah.
So if you can figure out what, like, some magical way to figure out what the arcs is, it's totally not just multiplication, but.
Well, it's the arcs added together. but-
Wait, what are we proving
Well,
exactly?
okay, so
but the
if
arcs-
you.
We're proving that the arc or that the 2 inscribed angles add to 180 and are supplementary.
Numeric value is just BAD and BCD, and you have what BAD and BCD is equal, it's just not that yet.
Right. So how could we maybe make this equal? Because we have the measure of angle A plus the measure and the measure of angle C being equal to half of those arcs. So how could I represent half of those arcs in this equation now?
You have it.
Can't you just
Say again?
measure?
Yeah, if I divide everything by 2, right? So now I have 1/2 the measure of arc BAD plus 1/2 the measure of arc BCD. And what's 360 divided by 2? Yeah.
Like, kind of what I was gonna say.
Nice. And that is the division property of equality.
To write so small.
I dotted my I 3 times, but 2 of them were in the wrong place.
How?
it's okay, Mr. Barr. You're not an English teacher. This is
Yep.
you're a math
Okay.
teacher.
Well, I go division sign, prop, period, equal sign.
Yeah, that's nice.
Yeah, I can.
Okay, now how can I say that the measures of my angles are equal to 180?
Measures of your angle.
Just substitution.
Yep.
And that's gonna be the definition or substitution.
Ooh. Oh, substitution. Oh my gosh, that was.
I'm telling you, it's so trippy. And the final step?
That's our side.
3 dots.
No, because what are we trying to prove?
That those 2 angles equal 180.
No.
Oh, that they're supplementary, so you have to write those supplementary. You
No,
put
that
the
there are
definition
2
of-
inscribed.
We already know they're inscribed, because it's been given.
Oh yeah, yeah, yeah.
Got.
Okay, they're kind of far apart, but whatever. It worked. That's a large dot.
Beautiful.
Oh, when you gave me the word for math, Mom was like, "Are you gonna be a math teacher now like me?" I'm like, "No."
Wow, just crushing our hopes and dreams. Jeez.
You know what, Merval? If nobody's here to replace you after you die, I will.
Jason, you're
Somehow
assuming this
after
school will
he
be open for that long.
retires.
Why does everybody die?
Yeah, why?
Everybody dies.
Yeah.
I really hope I don't die before I retire.
That would be unfortunate.
All the protein.
Think of all the golf I could play when I retire.
All the protein
Bro,
just
that's
comes
what
back.
my
Mr. Bo, you're gonna be playing golf and you're gonna slip a disc and be like, oh my back. They're
hope
gonna
not.
tell
Maybe
you.
his knee, get it right.
Yeah, his knee.
All right.
Merval,
Seriously, this is like I have the juiciest orange with me right now. It will not stop.
That Then just eat it all
Like
in one
I'm
bite.
trying to do the proof
I
and
already-
eat the orange, and it's just like bursting.
The juiciest orange of them all.
I don't know why you're not.
Just eat it in one bite then.
I'm not an animal.
It's a cutie, just pop it in your mouth.
It starts so fast, so you just see us all shuffling out.
Oh.
Mr. Ball, are you a plain
My
taco
favorite
kind of
is
guy
definitely
or a
volleyball.
cheesy Dorito
It's
taco
just
kind of
four
guy?
people.
A plain what?
Taco or a Dorito
But then you have
taco?
beautiful.
I'm not a huge fan of tacos. I like burritos.
Okay, you know that.
Okay,
The Dorito-
so what I want to know is how could we construct circles that are inscribed inside of these triangles? Because we constructed circles that were circumscribed, right? That were outside of the triangles.
What?
Me and William just looked at each other and it was beautiful.
Don't do that. How about when they're inscribed inside? So that means how could I figure out the center of like a circle like this where it's touching at a tangent point here, tangent point there, and a tangent point there?
Trying to
Could
figure
you
out
do
if perpendicular bisectors.
So perpendicular bisectors were what we did for the circumscribing of the circle to get it all the way around the outside. But how about for the inscribing?
What do we do? The whatever.
What'd you do?
Where like you
Altitude?
get a point that's
No.
perpendicular to the one line it intersects with the
Ooh, maybe an angle bisector. You could try that. So go ahead and construct some angle bisectors and see if that gives you a center, the incenter.
Wouldn't the perpendicular bisectors give you the center?
That gives you the circumcenter,
ball.
where you can circumscribe this triangle or the circle outside of the triangle, but we're looking for a way to inscribe the circle inside of the triangle.
Hey, Merbal, was the chisel handed over to you at any point? Because I left it there on accident and it's gone.
I have no idea where it went.
Mr. Ball, can I go get my compass?
It's officially gone forever. Or it's in the garbage.
It's actually findable this time. Every time
Nice.
I put it back.
Does anyone have a question about how to construct your angle bisector?
It's been a minute.
You know, I just need a.
Why is the
line.
garbage over there?
'Cause it feels like being over there today.
O'Reilly.
So
Does anyone need a refresher on how to bisect an angle?
yes, that'd be lovely.
Okay, great. You need to start, if we are to bisect angle C, you start with your point of the compass on angle C. And you create an arc that intercepts both of those sides.
Okay, so I'm gonna draw a straight line with a curve through it.
Then, you will place your point at the point of intersection between the angle sides and your arc, one at a time, with the compass just being greater than halfway across. And you will create two more arcs. One there, that intercept each other. And then you will draw that line that goes from the vertex through the point of interception of the arcs, intersection.
We're doing it with all of the points, yes.
You need to do it with at least two.
Does that look economically correct, psychologically correct?
Economically.
Draw it with the straight edge, though.
Oh, okay. I have a straight edge somewhere.
What if you don't got a straight edge anymore?
Is the side of your paper straight?
I don't know, maybe.
You got a straight edge then.
Did you just say maybe? Jason, be smart.
Please don't insinuate that he's not.
Well, what do you mean?
No.
Shh. Hey, you guys, please stop singing.
Hey, William has to sing in Spanish.
I've gotten singing for classroom and it was really good.
Shh.
Do you want us to do it with all three?
I want you to do it with all three. Yes. Thank you.
Yeah, there's two. You lied.
2 angles, all
Oh,
3
I was
triangles.
like, you said only 2.
You are correct. Shh. Do it with all 3. Don't waste time.
Are they doing rockets third period?
Yes.
Can we come watch them?
No.
What if our third period says yes? There
No.
we go.
Yes, because Dr.
Okay,
Allen is
shh.
going to allow
You guys.
us to do that.
Shit, Rocky.
Is your thing supposed to glow blue?
Oh yeah. They're connected to my phone.
So
My
confused.
headphones are connected to my phone, so when they're connected, they do a flash.
Okay.
I was very confused.
So we should all have those done? Sherry's not having them all done. Get them
Yeah,
done.
I'm on the last one.
Good.
They are really into that computer game.
He's talking about this, being surprised that he doesn't have jaundice, and is like, it's an entire page just about him, like,
About him
it
not
could
having
become
jaundice.
jaundice, but it's been not jaundice for so long, and it's just close to jaundice, and I'm reading like, what?
Oh, Merbal.
Yeah.
When you were announcing the science thing to give you're like, yeah, and who always makes Quizlets for every test. My dad leaned over and was like, what's a Quizlet?
Oh my gosh.
The thing that helped me the most.
Did you tell him?
No.
It's like, Dad. Ugh.
I said, tell you later.
What
and
did
then
you
I
say
just
to
never
Kristen
did.
afterwards?
How do
Mm.
you explain Quizlets to some...
Online flashcards.
That's exactly how to explain it.
They have but they got the meteor game and everything too. Meteor game.
Should have been sitting there with him, because then you would have been able to answer
Yeah, I
that.
was golfing. I was living my best life.
All right. So now you should have a whole bunch of these circles, and all of the sides touch the circle at a point of tangency. Okay? And what we're going to look at is what are some of the things that we could get that are interesting with the point of tangency.
Wait, do we need to draw the circle?
Yeah,
Oh, smart. I don't know.
you do need that. You should draw the circle with the compass.
Compass sucks.
So,
So flimsy, so it changes my angle.
no.
I can't draw a circle that small. It's not.
Yes, you can. Lean and drag.
But,
your
like,
compass.
It changes the angle when I like.
Move your
it's
paper
so-
instead of your compass.
It's so flimsy.
It'll change it less if you lean and drag also, rather than like try to
No,
push it.
start.
Well, it's kind of very lightly done. My favorite song was Beautiful City.
Who's what?
Beautiful City.
Oh my gosh. This compass is
I love
terrible.
the graph for it, like the
Logan
whole
was great, though.
recording. Logan's so good, but he's like, I think that and Elegance are my favorite songs, like, out of, like, performance. I think my favorite performance of the songs we have is World Will Know. I think that one's really, really good.
I'll be sleeping in the street
You already sleep on the street.
in a less neighborhood.
I'm never going to stop making references to, like, Matt's lines, just like,
Wait,
like,
what's
just
the word?
What?
There's a he's paying rent to live on a street?
keep your shirt.
No, it's because he has no money. And
Oh.
they're homeless.
That's
So then you
unfortunate.
can walk to the same neighborhood regardless of if you got $1 or no dollar.
No, because what he's thinking.
Actually, you need to pay to get
I
okay.
already sleep on
But
this.
what do you mean?
In
Where
worse
he sleeps
neighborhood.
on the street? That's free.
No, sleeping on the street's not is free.
You have to have permission, don't you?
No, you don't.
From, like, if it's a private,
Is it public property? If it's in a private area, I think you can get there, but commercial areas?
This one kinda goes over a little, but.
If you can sleep on a commercial property, that's how you know you're a rich homeless person.
It's fun.
Oh, how did that even move?
Like, if you get a car, then I can understand. It's like, yeah, you gotta drive the car to the nice neighborhood. Or just not being
It's
able.
set in like
Exactly.
In
the
New York.
late-
They still got
late
cars. The
1800s.
Benz don't.
All right. I need you to get your McBooks out again.
again.
Or Brooklyn is the worst neighborhood.
Oh my god. I'm still in it.
The reason why is because in the show they're all terrified of Brooklyn.
Because of the techniques that were there.
And then there's a song called Brooklyn's Here in the show.
Does it happen near a bridge?
No.
Does it happen near water?
No, G. Wow.
Happens near water.
That's
Okay. This is what your goal is for this one.
For some reason I think I know what you're talking about.
Shh. This is what your goal is for this one. You are trying to determine the relationship between this angle and this arc.
Go back to class.
You posted that one. I was like,
Angle B and arc AC. The minor arc. That means the smaller one formed by A and C.
Oh, that's on this or
Yeah.
So we're
It's
going back to the
backwards.
software, okay.
Yep, that's why I asked you to get out your MacBooks.
Okay, so you said B, so this B is C, top is B, middle is F, bottom is B. Okay.
Correct.
I'm actually gonna switch the points on my paper so I can actually comprehend this.
Okay. Not this one. You should get one that looks like this. It's a different one on Classroom.
Except it's backwards.
You need to reload, I think. There you go.
The issue is that it's backwards, Mr. Wall.
Why is that an issue?
Because it makes it more complicated to
Yeah.
comprehend.
Alrighty.
Brain don't work with it backwards.
Okay, move the point to the other side then.
It just enlarges.
Zoom out, and then just go ding.
Zoom out.
Oh, you can move the text boxes. Okay.
So it has measurements of the arc and measurements of the angle.
So, it's,
Can we delete the
Yeah, so like,
Do you want us to start marking these with like on our paper with like the angle measures?
Well, you shouldn't mark it with angle measures because we don't know what this particular angle measure is. What I want you to be looking at is what is the relationship between, on the software, angle C and arc ED.
The circle is big now. How do I get it not big?
oh,
Zoom out.
They are.
Or
Zoom in.
C point.
major or minor?
Minor.
Okay.
What is the relationship?
Give me a second, I need
They
to
equal
file
360.
Do they?
The minor and major are.
Oh yeah, but I'm talking about angle C and the minor arc.
We're just doing another conjecture.
Yep.
I was like,
Oh.
They equal 180. Those two.
Okay, what if you change it? Do they still equal 180?
I'm not able to see the measure of the small arc.
So wait, what do you mean change it?
What do you? Yeah.
would
You may have deselected it.
wouldn't angle C still equal half of the? No. I always forget.
the arc.
The arc? Does it?
No.
Do math on your calculator and see, does it? Does the arc divided by 2 equal the angle?
Major arc? Or the minor arc?
Minor. We're dealing with the minor arc only.
The major.
65.8.
Does maybe not that one. Hadassah, what did you say they were?
Like for what part?
What do you think maybe the conjecture could be?
The they're gonna add up to 180.
I said
Okay.
they equal 180.
That they equal 180, okay. Does that seem reasonable? Are you seeing that on yours as well? Others?
Yes.
No, but,
What do you think we can say?
I'm not sure. How do you get to see the measure of the arc?
Over here. Scroll up. Scroll down.
What are you doing, text? What did Like it's just, like I can move it around and I can see that.
Try just clicking on that.
It clicks on the whole thing. And if I can't even like shift click or.
You can actually move the text itself.
Maybe just redo button. There you go.
I like that.
Okay, so do we have concurrence? Do you have confidence that maybe that is the correct answer?
That minor arc, this angle equals 180, yes.
Okay. So the conjecture would be the measure of angle B plus the measure of arc AC equals 180, yeah? Does that seem reasonable? Okay,
Oh, my whole leg fell asleep.
Are we proving it?
we are proving it.
When is
They
it-
gave us room, so I'm
when is it
happy.
equal?
180 degrees.
Like, look like a weird bead, that's why I was like,
Ah. Okay, so go ahead and shut your MacBooks again.
no more MacBook.
Goodbye, MacBook.
It's a MacBook.
Okay, now how could we prove this?
Start with the given.
What is the given?
I'm out of that.
Well,
Angles formed by lines that are tangent to a circle.
What is that given?
As J.
Should do minor
That
arc
is a-
DE plus major arc DE is equal to 360. Or no, we have
You
to state.
could, but we don't need
as-
that. I also want you to name them as A and C again. What if I draw those two lines? What kind of lines are those?
Radii.
Radii.
Oh, my foot is.
Do we know anything about the way that a radius meets a tangent line at the point of tangency?
Always equal.
It's always equal, and what is it always equal to? What?
180?
I'm talking about angle like BCJ.
Oh, 90.
Yeah, that is always 90. It's part of the definition of a tangent line is that it meets a radius at the point of tangency at a 90-degree angle.
Doesn't that make BAJ also 90?
Yeah, that's also 90.
Look at, there's some.
And now we have this quadrilateral shape where
Looks like a kite.
it does look like a kite. Do you think it is a kite? It is. We're not going to use that in this proof,
It is.
but it is in fact a kite. That's very good. Okay. So now we've just got angles B and angle J left. But we want to make a statement about this arc AC and angle B. What do we know about the relationship between arc AC and J, angle J?
And then this is the same.
How do we know that they're the same?
Because it's the central angle.
Yeah, it's the definition of central angle, right? So the angle that, or the arc that it intercepts is equal to its measure. That's the definition of it, okay? What do we know then about angles J and B?
They're tangent.
They're not tangent.
Are they congruent?
They're not necessarily congruent either.
We're trying to say they're supplementary.
Are they-
We're trying to say they're supplementary. How could we say that they're supplementary? What kind of shape is a kite? A quadrilateral. What is the measure of the angles of a quadrilateral?
360.
360. And we have these right angles. Oh, so if we've got right angles, subtracting from 360, we've got two of them. So what's 360 minus 180?
180?
It's just 180 left, right? So then we could say angle B and angle J add up to 180. And we know that arc AC is the same measure as angle J. Boom. So then we could say the measure of angle B plus the measure of arc AC equals 180 by substitution. Okay? So, let's formalize that.
There's a lot
What do
of
you
room on this
mean?
one.
This one has so much
It's
room.
longer.
That's
Better.
okay.
Okay.
Right into the
So, what are we given?
that.
Right into no.
Okay.
Well, first you
Circle J with tangents AC meeting angle B. I don't know.
Circle J. It's good with tangent lines AC. Sorry, A, B, and BC.
Beef and bang burrito.
Jason, where do you know where you and Tim are going?
Shh, boys.
Lines.
If you are not writing, you should be thinking about the next step of a proof. Here we go.
For the last part.
A, B, and BC. Yep. Okay, we can see central angle J also. And central angle J.
Can we then talk about the right angles or no? Would that be later?
We will need to talk about them, but we will need to talk about them later. That's actually a great second step, Jacob. So angle BAJ and angle BCJ are right angles. And that's the definition of tangent. I'll say tangent line because we don't want to confuse that with the trigonometric ratio of tangent.
What's the difference with those?
Tangent of a right triangle is referring to the opposite side divided by the adjacent side. Tangent, this is just a same word, but a different kind of reference because you're talking about the tangent of a circle. Now, what else did we say we know?
Angle B and angle J.
something more true.
That's what we need to get there. We don't know that yet.
Well, we say they're right angles, but won't we also have to say that they're 90 degrees because they're right angles if we want to use the 90 degrees at all?
Yeah. So the measure of angle BAJ is equal to 90 degrees. Actually, I'm just going to say is equal to the measure of angle BCJ, which is equal to 90 degrees. That's by the definition of right angle. Now, what else do we know? We've used tangent lines. In the given, though, we also have central angle J. What is about central angle J?
Central angle J equals arc AC.
We can't just say the angle and the arc, but we can say their measures. So the measure of angle J is equal to the measure of arc AC. That's by the definition of central angle. And now, we've made statements now about all sorts of things. So let's maybe talk about...
Can we, because we compare it, we can say that angle B and angle J both
Well, we need to say that they're equal to 180, but how do we get there?
because we added the 90s and then subtracted by 360.
So before we can just get there, or like we have to say that in the proof now.
Wait, so we have to say that it's a quadrilateral, and so it equals 60.
We can kind of see that it's a quadrilateral, so we don't necessarily have to state that because we can see it. So we can just say that the angles all add up to 180 or 360. What?
My brain was like, isn't it just the half thing again, where it's like half?
Not quite. That's only for inscribed angles.
Oh, we gotta say that it equals 360 first, and then we can say that those angles equal 180 by dividing.
And this is by the definition of a quadrilateral.
Does it have to be in that exact
Wait, can
order?
you zoom in on that just a little
No, you
bit?
just have to say that all of it.
On 5.
Adding it.
Thanks.
Just cut it out with angles.
Yeah, and I guess under step 3, we also could have just said the measure of angle A and the measure of angle C. Because that's what I'm using down in step 5. And even 2.
Now we just said that it all equals 360, so and then we do the 90 degrees minus the 360.
So we have to say the 90 degrees first, and then we can do that. So we can go
Angle A.
90 plus the measure of angle J plus measure of angle B plus 90 equals 360. And that's
Substitution.
that is substitution. Now we can use the subtraction property of equality to say the measure of angle J plus the measure of angle B equals 180.
We just put subtraction without word. Reason.
I do want you to say subtraction property of equality.
Also, when you sneezed, all the hall lights turned on.
Oh,
It was really funny. He sneezed and then they just started going on down the hall, and I was like, "That's."
It's a powerful
obviously from the wall,
sneeze.
But it was just great.
That is a powerful sneeze.
It's how far germs can fly when you sneeze.
So now, what do I know that the measure of angle J is equal to?
What?
What do I know that the measure of angle J is equal to from previous statements?
MAC.
The measure of arc the measure of arc AC. And that's again by substitution. Oh, look at that. That's my conjecture.
Dot dot dot.
Dot, dot, dot.
What is?
Now, if I had made my conjecture as supplementary, which maybe I should have, but we didn't, then I would have needed to say that they are in fact supplementary, but
Just look at. I'm proving that.
I'm testing the pressure touch of this. That's all just by pushing with different pressures.
That's cool.
Whoa.
When you're angry and you express it.
I see the face, not anymore.
Anywho,
Anywho.
We proved it.
we did prove it. Oh, wait, I needed that.